Take a thick block of glass and bend it. It resists. That resistance, its stiffness, its Young's modulus, is not written into any law of the atoms. No single atom carries a stiffness. The stiffness is collective bookkeeping countless atoms, each nudged off equilibrium, each pushing back. In 1967, Andrei Sakharov proposed that spacetime is exactly this kind of material. Curving it costs energy, he said, not because nature carries an Einstein Hilbert term in her pocket, but because the quantum vacuum, every field integrated out, resists being bent. And that resistance is 1 over g. Gravity is the elasticity of the vacuum. Now, Sakharov left a metaphor with no atoms in it. On the chakra lattice, the atoms are literally there. They are the rotors. So the case for this chapter is not an elimination. It is a calculation. Bend the lattice, integrate out what the bending costs, and see whether Newton's constant falls out of the lattice spacing. One thing before we begin. Advaita Chakra Theory is a speculative, exploratory framework, not established, peer-reviewed physics. Much of what follows is honest conjecture that still needs validation. Watch it in that spirit as ideas to test, argue with, and refute. Open the file. From part 1, the substrate is, to quadratic order, a lattice of harmonic modes governed by one master dynamical matrix, D of K. Its spectrum has exactly one gapless branch, and that branch is the emergent light cone of chapter 3. C effective squared equals A naught squared times J over I. Every other branch is gapped, with a gap set by the locking scale. Sakharov's question, asked here, is what those gapped branches cost when you force them to live on a curved cone. So split the chakra field into a slowly varying background plus a fluctuation. The fluctuation obeys an operator whose leading part is the D'Alembertian of the emergent metric plus a potential carrying the gap and the curvature couplings. Integrate the fluctuations out, once around the loop, and the induced action is a functional determinant summed over species, bosons entering with a plus, fermions with a minus. And here is the one input value. The finite lattice spacing supplies the ultraviolet cutoff lambda star equals h bar psi effective over A naught. Not a formal regulator, a physical scale the substrate carries. Now the technique, and let me be exact about whose technique it is. Write each determinant in the proper time representation and integral over tau of the trace of E to the minus tau to the operator divided by tau with the lower limit supplied by the cutoff. For an operator whose leading part is the D'Alembertian of the emergent metric, the diagonal of that heat kernel has a known asymptotic expansion, the Seeley-DeWitt expansion, 1 over 16 pi squared tau squared times the spacetime integral times A naught plus A naught plus A1 times tau times R plus A2 times tau squared times curvature squared, and so on. Those coefficients are not free parameters. They are fixed numbers, determined entirely by the spin and statistics of whatever runs in the loop. A real scalar contributes 1/6 of R, a Weyl fermion 1/12, a gauge vector 1/2. All of this is standard heat kernel machinery, DeWitt, Gilkey in the textbooks for 50 years. Tag it standard and move on. What is specific to this theory is only the lower limit of that integral. The cutoff is not a regulator to be sent to infinity, it is the lattice. Do the proper time integral term by term and watch what the powers of tau give you. The tau to the -3 piece integrates to the 4th power of the cutoff, a constant, a vacuum energy. The tau to the -2 piece integrates to the cutoff squared, multiplying R, that is the Einstein Hilbert term. The tau to the -1 piece integrates to a logarithm of the cutoff, multiplying curvature squared. 3 terms. 3 divergent structures, quartic, quadratic, logarithmic in that order, and every one of them descends from the single expansion we just wrote down. Nothing was inserted between them by hand. Look at the integrand on screen. Near the cutoff, at small tau, the quartic piece towers over everything. As tau grows, the ordering reverses, and the logarithmic tail survives longest. Each power of tau is a different term of the emergent gravitational action, and the lower limit, the lattice spacing, is the only place a scale enters at all. The dimensionless prefactors are nothing but the Seeley-DeWitt weights, summed over the species running in the loop. Now match term by term onto the geometric action, and read the coefficients off. The constant piece is the vacuum energy. The logarithmic pieces are the higher derivative couplings, and the coefficient of R is, by definition, 1 over 16 pi g effective. So 1 over 16 pi effective equals C1 times lambda star squared. Substitute lambda star equals h bar c effective over A naught, and dimensions do the rest. G effective goes like A naught squared. Newton's constant is set by the lattice spacing alone. Turn that around. Ask which spacing reproduces the measured value of G. 6.67 times 10 to the minus 11 in C units, and you land on the Planck length 1.6 times 10 to the minus 35 meters. That is the derived claim of this chapter. The Planck length is the lattice spacing, and gravity's coupling is not a fundamental input, but the elastic modulus of the rotor vacuum, and it arrives with a consistency lock. The very same spacing fixes the Lorentz-violating scale of chapter 7, so the measure G predicts that scale to be Planckian, comfortably below every current bound. One number, two sectors, no free fit. Now the bill. The same loop that stiffens the vacuum against bending also endows it with a vacuum energy, the leading coefficient of the very same expansion, not an optional extra. Its scaling is derived. The vacuum energy density goes like 1 over A0 to the fourth. Its magnitude is a disaster. Feed in the spacing that made Newton's constant come out right, take the prefactor to be of order 1, and the vacuum energy density comes out about 10 to the 122 times larger than the dark energy we actually observe. Say this plainly. The number that makes G right makes the cosmological constant wrong. And this is not a failure special to this theory. Every quantum field theory that has a vacuum inherits it. This substrate is no better and no worse placed than the rest of physics. But do not file it as hopeless, because this theory does come back to it, and not by the cancellation you might expect. Because the substrate spectrum is fixed rather than chosen, the alternating boson and Fermion signs in that sum are not a tuning knob. That is worth knowing, but it is not the escape. The escape is structural, and it arrives much later in the book. The shift symmetry of the locked ground state forbids a matter sector vacuum energy outright, and the Lieb-Robinson bound from chapter 3 cuts what remains off at the causal future horizon rather than at the lattice spacing. What survives is a density set by the horizon, not by the Planck scale. That argument carries its own hedges, and I will not spend them here. For this chapter, the magnitude stays open. Two loose ends, both labeled honestly. First, the logarithmic terms. They assemble into the Stelle higher derivative action, r squared and Ricci squared, and the Ricci squared term carries a massive spin 2 pole with a wrong sign residue, a ghost. That is derived here, and it has been standard since Stelle in 1977. But look where the derivation puts it at the cutoff at the lattice scale. Used as an effective theory below that scale, and every gravitational measurement ever made is far, far below it. The ghost is never on shell, and the Einstein-Hilbert term dominates its higher derivative tail across the whole hydrodynamic window. Second, and this is the real open number, the prefactor C1 is a weighted sum over the substrate spectrum, bosons entering positive, fermions negative. Attractive gravity is exactly the statement that this sum lands positive. That is not assumed here, and it is not yet evaluated. Because the mode content is fixed by the master matrix rather than picked by a model builder, the sum is a well-posed computation, and a completed sum returning a negative C1 would falsify this gravity sector outright. The verdict. Derive the induced Einstein-Hilbert action out of one loop and one heat kernel on the substrate. Derive the scaling 1 over G effective goes like lambda star squared, hence like 1 over A0 squared, hence the Planck length is the lattice spacing. Derive the cosmological term and the Stelle sector as the first and third coefficients of that same single expansion. Standard, and named as such the proper time and Seeley DeWitt machinery, the Perspin weights, the ghost. Sakharov's, not this theory's the induced gravity idea itself, from 1967. And here is what is not claimed. Not a value for the prefactor C1, not a solution to the cosmological constant problem out of this chapter's heat kernel. The substrate does have a route out through the shift symmetry and the causal horizon, and part 9 takes it as far as a number. But that is a closure within this theory, resting on premises it asserts rather than proves, and it is not a result the wider field has weighed. And not clean Einstein general relativity, because the same spacing that induces G also breaks exact Lorentz invariance. The honest identity of this gravity is Lorentz-violating scalar tensor gravity. Gravity, then, is the stiffness of one substrate against bending its own light cone. Next, Chapter 9, Matter, Stability and Back Reaction. What happens when you put something into the medium, and the medium pushes back? A word of acknowledgement. This work was inspired in part by the non-dual teachings of Sri Narayana Guru, that the creator, the creation, and the substance of creation are fundamentally one. Symbols from the Hindu tradition, the Sudarshan chakra and the Shivalinga, suggested the analogies behind the chakra model. They are acknowledged as philosophical and symbolic inspiration. The physics stands on its own. Thank you for watching. If this made you think, the book and the next chapter are linked below. Until then, one substance and how far it reaches